Welcome back. This is the third lesson recording for IM2, January 25th, 2021. Let's put everything together that we learned. Okay, so if you have a quadratic equation with vectored form with negative 0.5 parenthesis 2x minus 1 multiplied by 2x minus 7, can I graph this? Okay, what are the key features that I should be taking a note of? First question is this a graph going to be opening up or opening down? Well, to decide that, you look at the multiplier right here. You're multiplying by a negative number. Okay, so that means, what does that mean? It's going to be opening down. Okay, so it's going to look like a parabola that looks like this, a sad face parabola, if you can put in two eyes. Okay, so it's going to be opening up down, so that gives us some idea. What about the x-intercept? To find the x-intercept, we set the equation to be equal to 0. So that means negative 0.5 multiplied by 2x minus 1 multiplied by 2x minus 7 is going to be equal to 0. Why is that? Because for x-intercept, y value is always 0. Okay, from here, I take my two branches and set each one of them to be equal to 0, because that's the zero product property. Or 2x minus 7 is equal to 0. And then we solve from there. So we add 1 to both sides to get 2x is equal to, so that means divide both sides by 2 and you get x is equal to half. So my x-intercept is half comma 0. So half comma 0 means it will be right here. What about my other x-intercept? 2x is going to be adding 7 to both sides. 2x is going to be 7. Divide both sides by 2. You get x is going to be equal to positive 3.5. Okay, so positive 3.5 is right here. Alright, so what about the vertex? How do we find the vertex? I know my two x-intercepts are half and 3.5. So we take an average of that. The x-coordinate of the vertex is going to be average of this. So that's going to be half is same as 0.5. And plus 3.5. Add those two together and divide by 2, because taking an average of it. 0.5 plus 3.5 is 4. Divided by 2 is just going to be 2. So I know the x-coordinate of the vertex is going to be 2. What about the y-coordinate? We're going to substitute the x to be equal to 2. That's the value that we just found into my original equation. So y is going to be negative 0.5 multiplied by 2 times 2x. 2 times 2x is same as 2 times 2. So that's going to be 4 minus 1, and 2x is 2 times 2, so that's 4 minus 7. That's going to give me negative 0.5 multiplied by 4 minus 1 is 3. 4 minus 7 is going to be negative 3. So that's going to be 3 times 3, which is negative 9, times negative half is going to be positive 4.5. So I have just figured out my vertex y-coordinate is going to be 4.5, like that. Okay, so let's put that down. 2 comma 4.5 is going to be right there. So I have my vertex 2 comma 4.5. Alright, lastly, y-intercept. Okay, how do we figure out the y-intercept? For the y-intercept, we're going to use the fact that x is always 0. So y is going to be negative 0.5. So you're substituting back into the original equation, finding when x is 0, what is the y value? We know that y is going to be negative 0.5 times 0 times 2 is going to be 0 minus 1. So that's just going to be minus 1 in the first parenthesis. And 2 times 0 is going to be 0, minus 7 is just going to be negative 7. So negative 1 times negative 7 is positive 7, times half is going to be 3.5. Okay, so that's going to be negative 3.5. Okay, so let's see. Negative 3.5 is right there. Does that work out? Yes, it does. And having the y-intercept should work as a checking point. So now join those points and draw a nice parabola that looks somewhat symmetrical. So that's my parabola. Now it's your turn to try to do the work yourself. Okay, we are supposed to sketch y is equal to negative x minus 5 multiplied by x plus 1. Okay, so in this case, what is the number that is being multiplied? There is no number. Okay, what is the default number when there is no number? It's like there is a 1 right there. So negative 1 is my multiplier. Does that mean that it's going to be opening up or opening down? Because we're the multiplier, the number we are multiplying in the front is negative, we are going to be opening down. Okay, it's a sad face parabola. Then let's find the x-intercept. To do that, we set each of the factor to be 0 because y is going to be equal to 0. So x minus 5 is equal to 0, or x plus 1 is equal to 0. So from here, I add 5 to both sides and I get x is equal to positive 5. And from here, I subtract 1 from both sides and I get x is equal to negative 1. So positive 5, 0 is right here. Negative 1, 0 is right here. Okay, so those are my two x-intercept. What about the vertex? Okay, to figure out the vertex, remember the x-coordinate is always going to be the average of the two x-intercept because it's going to occur right in between those two. The line of symmetry is going to be halfway between those 2 points. So to do that, we're going to add the two numbers 5 plus negative 1 and then divide that by 2. That's going to be 4 divided by 2. That's still 2. Okay, then if x is 2, what is y when x is 2? So you substitute x value 2 to my original equation. Don't forget my negative 1 here because that's going to come into play. So then 2 minus 5 multiplied by 2 plus 1. So that becomes negative 1 multiplied by 2 minus 5 is negative 3. And 2 plus 1 is positive 3. 3 times 3 is negative 9 times negative 1 is positive 9. So my vertex coordinate is going to be 2, 9. So let's plot that. 2, 9 is right here. Okay, then finally the y-intercept. Y-intercept is when we know that y-intercept, the x value is always going to be 0. So when x is equal to 0, y is negative 1 times 0 minus 5 is negative 5. To that, 0 plus 1 is just 1. So negative 1 times negative 5 is going to be positive 5. So y-intercept is going to be 0, 5. It's right here. Okay, so then now I can connect the points and draw my parabola that is going to be opening downwards as we said it was going to do. Okay, there we go. Okay, this time we're given quadratic equation in standard form. What do we need to do first? Okay, we need to convert this into factored form. How do we do that? We just factor. So y is equal to, but looking at this, a is not 1. Okay, so the first thing I should do is look for GCF. 6, 7, and negative 3. I cannot take any factors out, GCF out, so that means I do need to use either the area model or grouping method, which means then I need my diamond. Okay, 6 times negative 3 is going to be negative 18. The middle term is negative 7. So I'm looking for two numbers that multiply to negative 18 but that add to negative 7. What are the two numbers that multiply to negative 18 but that add to negative 7? That's going to be 9 and 2, and 9 times 2 is 18, but 9 minus 2 is 7. I know one of them is going to be positive, one's going to be negative. I want to end up with the negative 7 as a sum. That means the bigger number of the two has to be negative. So I have just solved my diamond so that I can now split the middle term, 6x squared minus 9x plus 2x minus 3. Okay, so then from here I am going to put in my two parentheses, factor the first half, 6x squared minus 9x. I can factor out 3x, and I know that 3x times what is 6x squared? That's going to be 2x. 3x times what is negative 9x? Negative 3. And then for the second part, I do not have any factors. Okay, so I just put 1 here, which is same as 2x minus 3. 1 times anything is that anything. Okay, I can see that 2x minus 3, 2x minus 3 is a common to both of the first half and the second half of the term. So that's going to be 2x minus 3 multiplied by 3x plus 1. So I have just factored or converted the first equation into a factored form. Now that I've done this, I can figure out what the x-intercepts are. So for x-intercept, well, first of all, there is no coefficient. That means the default is positive 1. That means it's going to be opening up. It's going to be a parabola that opens up. And for the x-intercept, I set the two of the factors to be 0. So that's going to be 2x minus 3 is equal to 0. Second factor is 3x plus 1 is equal to 0. Two different branches, okay? Two separate equations. Then I add 3 to both sides and I get 2x is equal to 3. So divide both sides by 2 and I get x is equal to 1.5. Here I subtract 1 from both sides. I get 3x is equal to negative 1. And then divide both sides by 3. So I get x is equal to negative a third. Okay, so then 1.5 is going to be right here. Negative a third is going to be right here. Okay, now what about the vertex? Okay, so vertex is going to be the average of the two numbers. If the x number is going to be the average of the two x-intercept, that's going to be 1.5, which is going to be same as 3 over 2. I am going to keep it as fractions because I want exact number. Plus negative 1/3 or divide by 2. Okay, how do I deal with fractions? I need to add, if I'm adding, I need to turn it into common denominator. It's going to be multiply top and bottom by 3, so that becomes 9 over 6 minus, for this, how do I convert this to have common denominator? To get to 3, get to 6, I need to multiply by 2, so I'm going to multiply 2 top by 2, so it's going to be equivalent to negative 1/3 is equivalent to negative 2 over 6, and all of that is going to be divided by 2. So then here I have 9 minus 2 is 7 over 6. Divide by 2 is same as multiplying by half. Then this leaves me with, when you're multiplying fraction, you multiply top with top, bottom with bottom, so that leaves me with 7 over 12. So I know that the vertex x coordinate is going to be 7 over 12. If that is case, what is the y value? When x is 7 over 12, what is the y value? Y is going to be 6. I am going to use the factored form because they're usually a little easier calculation. So 2 times 7 over 12. That's going to be 7 over 6 minus 3 multiplied by 3 times 7 over 12. That's going to be